23. Which quantity has both a magnitude and a direction? So what does that mean, magnitude and a direction? Hopefully that rings a bell from the beginning of physics. That's a vector. Vector has both magnitude and direction, which is separate and distinct from a scalar, right? A scalar quantity, which only has magnitude, doesn't have a direction. So, for example, a velocity would be an example of a vector. It has magnitude and direction, whereas speed only has a magnitude, it doesn't have a direction like velocity. So, vector, scalar. That's just a little reminder there. Let's talk about these. Work and energy are actually the same, right? We talked about that in the last video. They have units of joules. You can't use joules in a particular direction. So work and energy don't really have a direction. They can't be vectors. And also, helpful hint for multiple choice tests, if two of them are kind of the same thing, they can't both be the answer. So it sort of makes sense right off the bat to cross out energy and work. And then power is, we also talked about in the last video, power is the watts, that's the unit, which is really joules per second. Watts are joules per second. So if the joule is not a vector, if the joule is a scalar, and now we're dividing it by time, we really aren't giving it any direction. We can't make it a vector. So if work and energy aren't vectors, then there's no way the power can be a vector. The only thing left is impulse, so that must be the answer. But let's, rather than just eliminating, let's also think about what the impulse is and whether that makes sense. Impulse comes in when we talk about momentum, right? And we say that the change in momentum equals the impulse. So this J isn't joules, by the way. The J is the symbol that we use for impulse, and P is what we use for momentum. So oftentimes you end up setting these things equal to each other. So the only way there can be a change in momentum within a system is if an impulse acts on the system. And it's important to note what direction that impulse is acting in. So that is absolutely a vector. If it acts in some other direction, then the change in momentum to the system will be different. So we have to keep track of all that. And when we do momentum and impulse problems, we certainly do take those directions into account. So by all means, the impulse is a vector.